There are numerous foreign and domestic companies manufacturing and selling modular aluminum framing systems. They all employ the basic T-slot fastening system. Using an oversized fastener tightened to a high torque in an effort to keep assembled parts from moving when external forces are applied. Note how the arrows showing the points of contact are all parallel, indicating that the frictional force is in a single direction or plane. In static situations, this assembly may never experience an issue. However, in dynamic situations, the pivot points created by the fastening system allow for movement or slippage between the components, causing misalignment and loosening of the fastener, compromising the assembly. In addition, the oversized fastener torque 2 specification can measurably distort the profile well beyond the extrusion tolerances, pushing it outward and compounding this alignment. The key to correcting the issues with the existing T-slot fastening system is in eliminating all pivot points by creating a mechanical lock. First, anchoring the nut in 2 planes into the V-shaped area of the extruded profile. As the fastener is tightened, the nut rotates up and locks into the opposite side, anchoring itself into a 3rd plane. The upper bracket now slides into position and is precision aligned to the extruded profile, creating a 4th locking plane. As the fastener is brought up to its required torque, the appropriately sized bolt stretches slightly. Friction is created in a 5th plane between the bracket and the profile, and the entire assembly is pulled together to form a mechanical lock. Even when subjected to large direct external forces that attempts to separate the 2 attached components, the stretched bolt acts like a spring and keeps the assembly in precise alignment.